So what are we going to have to do? So the answer is 1 over the square root of x squared minus 1. Any questions? Now, here's my question to you. Would you like to continue with some word problems, or would you like to stop for a few minutes and work some more on these? Yes? This type or just any? With log? Yes, Ella?
Like 65. I don't
65 from here? There is no 65. It goes up to 56. Say it again.
This one. There's 2 long.
Which one? Oh, you were talking about trajectories. Yes, 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 of course. Let's choose another one. So back to page 216. Let's look at the next one, 66. We look at 65. Let's look at 66 on page 216. And we have x squared plus y squared equals ax, and x squared plus y squared equals by. Perfect. Perfect example. Okay. So again, we're asked here the same question. Are these two families of curves orthogonal trajectories? Where is my starting point? What do I have to do first? Yes, find whether they intersect. Because if they don't intersect, how can they be orthogonal trajectories? If they have no points of intersection. So let's find the points of intersection. So here in this particular situation, so did I copy it correctly? And let me check again. Yep, I did. So here, if we subtract, this is what I would recommend. Multiply, let's say, the second one by -1. And then we will have x squared plus y squared equals ax. And negative x squared minus y squared equals negative by. And when I add these two, I get 0 on the left, and I get ax minus by on the right. That will enable me to get either x or y. You choose. Okay, so this is ax equals by. And then x is b over a times y. So far, so good? Okay, so now I have to go back. It doesn't matter where I go back. I have x, and I have to plug it in and determine y. It doesn't matter. Where do you want to go back? You want to go back to the first one or to the second one? Okay, perfect. So I have to square to put it in. So this is b squared over a squared y squared plus y squared equals a times b over a times y. So I have x here and I have x here. So here I had to square this, and I got b squared over a squared y squared. And here I had a times x, which is b over a times y. From this equation, somehow I have to get y. I see that these two go away. I see that I have to pull out the y squared. And again, I have here a squared plus b squared over a squared. And this equals by. Actually, I should move it to the other side. Since it's quadratic in y, how many solutions will I get for y? 2 solutions. First, I will factor out a y, and I get y a squared plus b squared over a squared minus b. And I know my first solution is y equals, excellent. And the second solution is b over this. B over a squared plus b squared over a squared. Because I have to move b to the other side and divide by the coefficient of y. So I have to flip the denominator, and I get a squared b. So I get two values for y. Y equals 0 and y equals a squared b over a squared plus b squared. If I got two values of y, most probably I'll get two values of x. And let me copy this. X equals b over a times y. So from when y is 0, how much is x? Very good. So now when x is b over a times y, b over a times a squared b over a squared plus b squared, I simplify an a with an a, so then x becomes a b squared over a squared plus b squared. So finally, can anyone give us those 2 points? Point A and point B. Yes, point A is nice. Very nice. 0, 0. And point B is? So it is AB squared, very good, over A squared plus B squared. And the other one is A squared B over A squared plus B squared. Okay, so after all this effort, I only determined that the two families of curves meet in 2 points. One is at the origin, and the other one at some point B. What is my next step? Yes, I have to differentiate. I'm going to copy them one more time. So we had x squared plus y squared equals ax, and we have x squared plus y squared equals by. Good. So let's differentiate. And remember, we have to make sure that we get two different derivatives. And because they are called the same dy over dx, put some suffix, prefix, whatever you want, so that you know that one is from one curve and the other one is from the other, okay? So from here, what do we get? 2x plus 2y dy over dx. And the answer is on the other side. Very good, awesome. So then from here, dy over dx is a minus 2x over 2y. And this is coming from the first curve. Put a little star or a bar or a number or something so you know it's coming from the first. Okay, now from the second one, 2x plus 2y dy over dx. Careful now. B dy over dx. Do we understand that? Because there is y on the other side. Are you okay with this? So now I do have first to move this term, factor out dy over dx, and then divide. So we have 2x equals b minus 2y and dy over dx, and dy over dx coming from the second curve is 2x over b minus 2y. Okay. So I have the 2 points. I have the two derivatives. What now? Yes. I determine the slope. This is the slope of the tangent line to curve 1. This is the slope of the tangent line to curve 2. For each point, but separately, right? For each point, I will determine the slope of the first curve and the slope of the second curve. And then I'll come back. For the second point, I determine the slope of the first, and I determine the slope of the second. And only if those products for A and the product from B are -1, then I'll say these curves are orthogonal trajectories. Ella, is this better? Yes? Okay, perfect. So then I have 0, 0. The point 0, 0. Let's find dy over dx when x is 0 and y is 0 for the first curve. And then for the second curve when x is 0 and y is 0. Okay. So here I'm in trouble. Because when x is 0 and y is 0, this is a vertical tangent. Vertical line. What happens here with 0 over 0? Well, this is 0. But the slope is 0 for the horizontal line. So a horizontal line and a vertical line, are they perpendicular at point A? Yeah, the vertical line and the horizontal line are always perpendicular, right? So at A, the condition is fulfilled. Yes, because this is a vertical line and this is a horizontal line. This has a slope that is undefined, and this has a slope that is 0. So therefore, at point A, the two curves are orthogonal trajectories. Now, let's see what happens at point B, which is ab squared over a squared plus b squared, comma, a squared b over a squared plus b squared. So I'm copying dy over dx here for 1, a minus 2x over 2y, and dy over dx for 2, which is 2x over b minus 2y. Okay. So I'm going to replace x and y in here. I'm going to replace x and y in here. And if this product equals exactly what? -1, then I'll say at point B, the condition is fulfilled as well. So let's plug in here x and y from point B. Awful, but that's what it is. So dy over dx for 1 is a minus 2 times x, 2ab squared over a squared plus b squared over 2 times y. So 2a squared b over a squared plus b squared. And I have to calculate this. So let's see what we get. The least common denominator in the numerator, please. Of course, there is no other. So then this it's multiplied by a squared plus b squared. So please dictate the numerator. Awesome. Very good. Minus 2ab squared. Great job. So I copy this after I simplify, and I have a cubed minus ab squared over a squared plus b squared. I flip the denominator, which is a squared plus b squared over 2a squared b. Luckily, these two go away. The numerator has a common factor that I would like to pull out. What is the common factor in the numerator? Very good. What is left in parentheses? A squared minus b squared. And I will simplify one of these a's. So I got a squared minus b squared over 2ab. When I replace in the second derivative x and y from b, what should I get? Negative 2ab over? Exactly. I don't know if I'm going to get it. I hope, because otherwise we'll spend the night here till I get it. So, be careful. Okay, here it is. So this is dy over dx for 2, which is 2 times x. 2ab squared over a squared plus b squared over b minus 2 times this, which is a squared b over a squared plus b squared. And actually, I'm going to sit here uploading my videos, and you're going to work on it if this doesn't work. Just kidding, just kidding. Okay, in the denominator, I need the LCD. Now, Kyle is really paying attention. He can hardly wait to say, you're wrong.
I would just write down yes and then not do any work.
Ah, right.
You give me full credit for that, right?
No, I will not. Okay, so b gets multiplied by a squared plus b squared. So we have a squared b plus b cubed minus 2a squared b over a squared plus b squared. I copy the top, which is 2ab squared over a squared plus b squared. I flip the denominator, but I have to be careful and see what I get here. I have a squared b with a 2a squared b and the b cubed. So that will be negative a squared b plus b cubed. Let me know if this is okay so far. I see it, it's okay. Nobody has to spend the night here. So these two go away. And I will have to factor out what in the denominator? A negative b. So then we have a squared minus b squared. A b goes away. So negative 2ab over a squared minus b squared. What did we say we were expecting? We're expecting the negative 2ab over a squared minus b squared. So the product of this, so I'm going to call this a, and I'm going to call this b. So a times b is negative 1. So the condition is fulfilled. Maybe I shouldn't use a and b, c and d, because we already have used, yes, let me do that. So this is c, and this is d. So c and d multiplied will give us negative 1, which means that at point B, the two curves are also, families of curves are also trajectories, orthogonal trajectories. Is this better? Yeah, a lot of work. Good. So I like to look at some word problems now. Nothing fancy for now. Let's just look at, number 8. 8 on page 234. So the next section, which is 3.7, is just applications in real life situations. Applications. Okay, so let's look at number 8 on page 234. Let's read the problem together. It says if a ball is thrown vertically upward with a velocity of 80 feet per second, then its height after t seconds is given to us. What is the maximum height reached by the ball? What is the velocity of the ball when it is 96 feet above the ground on its way up and then on its way down? and then we'll find something else. So S of t is given to us, 80t minus 16t squared. We're asked, I have to take notes on that too. S is in feet, time is in seconds. Feet, seconds, so I don't forget. Okay, what is the maximum height reached by the ball? And no, we're not going to graph a quadratic function because we are in calculus. So let's talk about it for a moment. Here's a function. It's not quadratic. I'm just drawing any function. Let's say f of x. At points of max min, can anyone tell us what is the slope of the derivative? Correct. That will always be the case. So a function has a max or a min where the derivative is 0, where the slope of the tangent line is 0. So here we're asked to find the maximum of this function, if it has a maximum. So what I have to determine first is find s prime. What will I determine second, or what will I do next? Set it equal to 0. Exactly. And that will give us the points where the function has a max or a min. Now, we will investigate further in chapter 4, something that is called critical number. But for now, we are fine. We are trying to determine whether the function has a max or a min. I know it has a max, it's quadratic, and the leading coefficient is negative. Because the correct form should have been this. So the leading coefficient is negative, the quadratic function must have a maximum. Okay, so let's differentiate s prime of t, and we get, if I put it in the correct order, negative 32t plus 80. I will set this equal to 0, and I get that t equals 80 over 32, or 10 divided by 4, or 5/2 seconds. In chapter 4, we cannot get away with this, meaning when we differentiate and we set it equal to 0, the derivative set equal to 0, it does not necessarily mean that this gives a max or a min. So for now, we're going to say I know it's a max because it's quadratic with a negative leading coefficient. But in the future, we're going to have to show that 5/2 gives a max or a min. And we'll talk about it soon. Okay? So now it says, one more time, what is the maximum height? So I only determined how long it takes till the maximum height, till it reaches the maximum height. But I did not determine the maximum height. So the maximum height is s of 5/2, which is negative 16 times 25 over 4 plus 80 times 5 over 2. That's how I get the maximum height. So I'll simplify, of course. I'm not going to multiply. So negative 4 times 25 is negative 100. And 5 times 40 is 200. So this is 100 feet. So this says that the particle, or whatever it is, the ball, reaches the maximum height of 100 feet in 5/2, or 2.5 seconds. Any questions on this? Okay, in part B, what is the velocity of the ball when it is 96? I'm dealing with a bug here. All of a sudden, I don't know if I killed it or not. Sorry about that. Okay, so part B, what is the velocity of the ball when it is 96 feet above the ground on its way up and then on its way down? How do I determine that? So we want to find the velocity when s of t is 96 feet. That's our next question. Find the velocity when the ball goes, so it's a maximum, right? So this is 96. I know this is not the maximum height because the maximum height is 100. We just determined that. So between this point, and then between this point and this point, on its way up, on its way down. What do I need to determine? I do have the velocity formula. I do have it, right? This is the velocity formula, is the derivative of the distance. So I can write that v of t, which is s prime of t, equals negative 32t plus 80. That I can write. But the question is, how do I get the time? Because I need to plug it in. The time needed, yes, I have to set s of t equal to 96. And I have to determine t, and of course I will get two different t's. One t between this point and this point, and another between this point and this point. So I will get t1 and t2. One has to be shorter than the other, of course. Okay, so the equation is negative 16t squared plus 80t equals 96. That was the equation, right? Yes. Okay, what do I do now? What type of equation is it? It is quadratic. Let's see if we can divide both sides by negative 16. I will move 96 first. Doesn't matter really. I hope we can divide both sides by negative 16 and clean it up. So 80 divided by 16, I think it's 5. And 96 is 6. So t squared minus 5t plus 6 equals 0. That's really nice because it's t minus 2 and t minus 3 equals 0. And I get that t equals 2 seconds and t equals 3 seconds. So then I have to determine v of 2 and v of 3. So the time needed for the ball to reach 96 feet before it reaches 100, which is the maximum, and it starts coming back down, is 2 seconds, and on its way up, 2 seconds, and on its way down, 3 seconds. So v of 2 is negative 64 plus 80, and v of 3 is negative 96 plus 80. So this one is 16 feet per second, and this one is negative 16 feet per second. Now you understand that the symbol in front of it, which is the negative or positive, has nothing to do with a negative velocity or a positive velocity. So what it means is that the slope of this tangent line here is positive, and the slope of this tangent line here is negative. That's all it means. And the slope of this tangent line at this point is the instantaneous velocity at that point. That's why it's going up, so it's positive. The instantaneous velocity here, it's the ball is coming down, so it's negative, because that's exactly the slope of the tangent line at those points, the instantaneous velocity. Has nothing to do with saying that I drive at negative 40 miles an hour. But if I talk about direction, so let's say for me, the positive direction is to go home. So when I come here, my speed, if I want the direction, I say it's negative 40 miles an hour. But it only means that I'm going from home here. And because I consider the positive, the direction going back home. But it only points out the direction. Okay, ready for another one? Let's look at the tank now. Okay, here it is, problem 18. Let's read the problem with the tank. Okay. If a tank holds 5,000 gallons of water, which drains from the bottom of the tank in 40 minutes, I already have information. The tank has 5,000 gallons, and it needs 40 minutes to empty out, right? Then Torricelli's law gives the volume V of water remaining in the tank after t minutes as this function. V volume equals 5,001 minus 1 over 40t, everything squared, for time between 0 and 40 minutes. Find the rate at which water is draining from the tank after 5 minutes, after 10 minutes, the rate after 10 minutes, 20 minutes, and 40 minutes. At what time is the water flowing out the fastest, the slowest? Summarize your findings. So if I, and I will not do that, but if I make a hole in at the bottom of this bottle, let's say I have 5,000 gallons here. Wow. And I make a hole in it. When do you think the fastest rate would be coming out? The water will come out of the bottle, right? When will be the fastest?
Right at the start.
Absolutely. That's the biggest pressure, right? It will come out as fast as possible. When will be the smallest? When it's almost empty, right? Good. So we know that idea, so we know what to expect. Ready? So let's copy the function. So this is problem 18 on page 234. And we have V of t is 5,000, 1 minus 1 over 40, correct? T, everything squared. T is between 0 and 40, and this is in minutes, and this is in gallons. Of course it is. I'm sorry, thank you. Thank you. My apologies. Okay, so I made my notes. The volume is in gallons, the time is in minutes, and I'm asked to find the rate of change at, what is it, again, 5, 10, 20, and 40. So T equals 5, 10, 20, and 40 minutes. The rate of change. So how do we start? Where do we start? What do we do? Of course, we have to find the derivative of the volume. So be very careful. This is the chain rule. We have to bring the power down and multiply by 5,000. Subtract 1 from the power, but 2 minus 1 is 1, and multiply by the inner function prime. But 1 prime is 0, so then I have to differentiate this. What do I get? Negative 1 over 40. Excellent. Do we all agree with this? Please stop or stop me and say, do it again. Is this clear? Perfect. Next. I will simplify. And what do I get? So this will be 25 and 1 0. Right? Because I simplify a 0, and then 1,000 divided by 4. So it's 250, correct? So then 1 minus 1 over 40 times t. So I will put this in the graphing calculator, and I will have 5, 10, 20, and 40, and this is in minutes, and this is in gallons. Per minute. That's the rate of change. The rate of change, or the derivative, has always a measurement unit coming from the top and a measurement unit coming from the denominator. Ready? So here it is. So let's put in the function. And we had 250, parentheses, 1 minus 1 divided by 40. I use parentheses for that. 1 divided by 40. Close the parenthesis. X, close the parenthesis.
Can't you distribute the 250?
Yes, you can.
Wasn't there a negative one?
Thank you.
Awesome.
Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. My apologies. Of course, there is a minus in there. I swallowed it. I'm not hungry though. Okay, second hand table. And we have 5, 10, 20, and 40. 5, 10, 20. For the same reason why we know it's negative, because it's not filling up. It's just emptying out, so it's negative. Okay, so the first one is negative 218.8. The next one, negative 187.5. Negative 125, and of course 0 at the end of the 40 minutes, because we knew that it will completely empty out. It will be completely empty in 40 minutes. So now the question is asking also, at what time is the fastest? We already know. The slowest? We already know. And summarize your findings. We already summarized them in a table. Any questions? Okay. 21. The force F acting on a body with mass m and velocity v is the rate of change of momentum. If m is constant, this becomes F equals m times a, where a is the derivative of v with respect to time, which is the acceleration. But in the theory of relativity, the mass of a particle varies with v as follows, where m sub 0, is the mass of the particle at rest, and c is the speed of light. Show that F is this. How do we think about this? So we look at F, and F says F equals m times a. We have m, and we have a. We also know that F is the derivative of m times v with respect to time. So we are asked to use the information we have and see and show that this is the correct result. Is it interesting? We would like to do that. Is that a yes? Would you like to choose another? We can choose another, or we can stay with this one. With this one? Very good. Okay, so let's take a look. And this is problem 21 on page 235. And I have a lot of things to copy here. So we have that F is d over dt of mv. So F is the force and is the derivative with respect to time of the product of mass and velocity. Okay, let's read on. M is a constant. Okay. This becomes, okay, F equals m, okay, where A is dv over dt. It says if m is constant, this becomes F equals m times a, where a equals the derivative, of course, it's the acceleration, is the derivative of the velocity with respect to time. So this is acceleration. But in the theory of relativity, the mass of a particle varies with v, so this is not going to be a constant. So we have m equals m0 divided by the square root of 1 minus v squared over c squared. m0 is the mass of the particle at rest, of particle at rest. c is the speed of light. Just find f. That's what they're asking us to do. Let's read the problem one more time and make sure we took everything into account, and then we will try to determine f. Okay, one more time. The force F acting on a body with mass m and velocity v is the rate of change of momentum, okay, which is the derivative with respect to time of the product mass times velocity. We have the mass and the velocity, v. Okay? Then, if m is constant, but it's not the case, if m is constant, that f is just m times a, where a is the acceleration dv over dt. But in the theory of relativity, which is what we are looking at, the mass of a particle varies with the velocity, and we know that. So this is the mass of the particle at rest, but the mass of the particle when it's moving, it depends on this. So it's this expression, where m0 is the mass, as I said, at rest, and c is the speed of light. Find f. Ready? So f is m times v prime with respect to time. Okay, and we know that dv over dt is going to be the acceleration. Okay, so this is the same with m, which is m0 over the square root of 1 minus v squared over c squared times v prime. Because m0 is a constant, I will put it out, and I will have v over the square root of 1 minus v squared over c squared prime. We know that v, which is the velocity, is a function of time. Okay, so let's differentiate. So f equals m0. This is the quotient rule, or we can change it into a product. It's up to you. You can say v over this and just use the quotient rule as is, or we can simplify this function a little bit. I will just take care of the denominator a little bit, or maybe even change it into a product. Let's do that before we start differentiating. So one option would be, you want to keep it as a product? You want to keep it as a ratio? No? Okay. So then m0, v multiplied by, but then I have to change this into something to -1/2. That's fine. But we have to find the least common denominator. So I'll come back. Let me just write it here one more time. So it's v divided by the square root of c squared minus v squared over c squared. I hope you agree with that. We find the least common denominator to be c squared. So then this whole expression changes into c squared minus v squared. And this becomes now v over the square root of c squared minus v squared. And the square root of c squared is c because it's just the speed of light, and it's a positive number. I don't have any questions there. So this will be cv over the square root of c squared minus v squared. So this whole expression changes into cv over this. So cv over the square root of c squared minus v squared, which also becomes, once I put c outside, it becomes, I'm going to erase this, m0 c times v times c squared minus v squared to -1/2. It's ugly, but no matter what we do, it's still ugly. If we keep it as a fraction or if we keep it as a product, it's still not friendly. Okay, so we changed it into a product, and now let's differentiate. Ready? So then f equals m0, and this is prime, of course, in all situations. This is always prime, is the derivative. Prime, prime, prime. Okay, so then m0c times the first function prime, right? So v, velocity v is the rate of change of momentum. Okay, and velocity v, okay. M is a constant, okay, and a is the dv over dt. So dv over dt will be the acceleration. So let's write dv over dt first, times c squared minus v squared raised to -1/2 and plus v times, now be very careful because we have to bring -1/2 in front, times c squared minus v squared to -1/2 minus 1, which is -3/2, and times the inner function prime, which is -2, times v times dv over dt. Now let's try and simplify this. I will factor out dv over dt because it's present in both. I will also factor out, I don't want to rush. I will also factor out c squared minus v squared at the lowest of the two powers. So this is out, and then c squared minus v squared raised to -3/2 is the lowest power of the two. So what is left from here? C squared minus v squared raised to -1/2 minus -3/2 is power 1. From power -1/2, we subtract power -3/2. We have -1/2 plus 3/2, which is 2 over 2, which is 1. So a c squared minus v squared is left. I should have not put parentheses, there is no need. Luckily for us, this with this, it's a product of 1. Then this is completely out, and this is plus v squared. Oh, gee, I like it. And I'm going to remove those parentheses because there is no need. Exactly, yes. That's why I wanted to remove them, not to confuse you. Good. So then F equals M0V, they say that this is A, this is C squared, and this goes to the denominator. C squared minus V squared to the third power. Okay, so now let's see what they want here. This is what they wanted us to come up with. So let me wait for a second for you to copy. Let's see what they wanted us to show. Now we can take a look at it. I didn't even want to look at it. So there is an M0, there is an A, but what they did, they divided top and bottom by C squared to get this. So if we simplify the denominator, removing C squared, and we put the C squared at the top, we're going to get the same thing. So let's do just that. So we can, so we had the M0 A, and what they did, they divided top and bottom by C squared V. sorry. They divided top and bottom by VC squared. So M0 times A, everything divided by, so I have the square root of C squared minus V squared to the third power, and I divide this by VC squared. Well, in order to do that, I have to write C squared minus V squared to the third, and put this in by squaring it first. V squared over C and C to the fourth, because I cannot put it in under the square root. Oops, I'm sorry, I exceeded by 1 minute. Can you finish this up at home? I don't want to hold you over. I'm so sorry. Forgive me. So once we put this in, then we can simplify top and bottom by either factoring out by force and SC squared V, and I can show you next time how we get to exactly what they wanted. But this is perfect. This is the final answer. But in order to show it exactly how they wanted it, then I need 2 more minutes, and I don't want to hold you right now.